Lecture 9, Part 1, Utility Provisions. In this lecture, we will talk about different sources of hot and cold utilities and how we can actually make a choice in terms of selecting a utility for a process. Okay, and this is lecture is related to ILO 5, where we again look at how to supply the hot and cold utility requirements of your process. So previously with Dr. Simon, you have talked about the need for hot utility QH-min and cold utility QC-min in your chemical process. And you have talked about maximizing energy recovery and so consequently minimizing the amount of hot utility and minimizing the amount of cold utility. Both hot and cold utilities significantly contribute to the overall operating cost of your chemical process. So by minimizing both the use of hot utility and cold utility, we can actually minimize the cost of operating our chemical process. You also briefly talked about what type of hot utility and type of cold utilities are available. Obviously, I think you have talked about steam as a source of hot utility and also perhaps cooling water as a source of cold utility. However, there are many different types of utilities that we could use, and we will be discussing these in the next few lectures. Here are some options that are available as a source of hot and cold utilities associated with a chemical process. So we could use these utilities in a singular way. We could provide all the hot utility to our chemical process in the form of something like MP steam, or we can provide a combination of hot utilities, like for example, we can combine HP steam with LP steam and flue gas. Okay, so this is optional. But how we decide that which utility to provide and how much of it to provide, that is the actually important question. And we will be looking at this in the next few lectures. So let's briefly look at the type of utilities, the hot utilities and cold utilities that we can supply to a chemical process. So the hot utilities are shown here with an inward facing arrow, while the cold utilities are shown here as an outward facing arrow. Okay. So in a chemical process, the highest temperature utility that we can provide comes from the furnace, and it actually comes from the flue gas, and the temperature of the flue gas is normally in excess of 2000 degrees centigrade, and it is associated with the burning of fuel inside this furnace. Although generally speaking the fluids of our process, we hardly actually expose them to these flue gases, and these fluids normally are heated below 600 degrees centigrade, because above that actually we might start to decompose the fluid. In addition to the flue gas that we can source from this furnace, we can also source hot oil that we can actually get from this furnace, and this hot oil can be a hot utility for our process that provide heat to our process streams, and then it comes back, and then we have a reheat of this oil, and then that's how the cycle continues. Obviously, for furnace we need fuel, and in addition to fuel we need to provide air. This air can be at ambient temperature, and sometimes we actually decide to preheat the oil, and to do that we can use some of the heat from either flue gas or hot oil to preheat the air. So this preheating of air in fact is actually a cold utility, because we are removing some heat from the system, and then this preheat air actually goes into the furnace and get burned there with the fuel. So here we have preheating, that is, as I said, is a type of cold utility. Obviously hot oil and flue gases are hot utilities. The most common type of utility that we can provide to our chemical process are in the form of steams that we can provide at different temperatures, and the temperature of this steam actually depend on its pressure. So high pressure steam would be hotter than the medium pressure steam, and medium pressure steam would be hotter than the low pressure steam. And these steams are produced in boiler that uses fuel and water that is preheated, and as such we have different levels of the steam produced in the boiler. So we can provide steam in the form of direct heat to our process, like for example LP stream directly to our process, MP stream directly to our process, or we can decide to use the steam to a steam turbine, and in the process we actually generate work, and obviously we can use this work in different forms in our chemical process, and then the exhaust of this steam turbine can be used to provide heat to our process. Okay, so this is an example of cogeneration where actually the hot utility is being used to produce power and heat for our process. The other hot utility that we can provide and is associated with power is through gas turbine. So the fuel is burned in gas turbine, and as such we get power for our system and also heat as a hot utility to our process. And this exhaust of this gas turbine can be in the range of 400 to 600 degrees centigrade, so high level of hot utility. Another form of hot utility that we can use is by using heat pump. So heat pump is a system or a device that actually use low grade heat, or the heat that is at low value, and then it consumes power. So this power we have to produce externally, and then we provide it to heat pump, and then it actually help transform this low grade heat into high grade heat that we can actually again provide to our process to satisfy its heating demand. Now, in terms of our core utilities, obviously we mentioned preheat as one form of core utility. The most common source of core utility is actually cooling or cold water or cooling water. And the cooling water temperature can vary largely, going from 10 degrees centigrade to 25 degrees centigrade, depending on the location of this cooling tower in the process. And if you want to go below ambient, then obviously we need to use refrigeration. And refrigeration can provide temperatures well below minus 100 degrees centigrade. However, refrigeration system relies very heavily on compressed power, and as such these systems are very costly. So we have a choice of many different types of hot utilities or cold utilities, and we will be looking at these in a bit more detail as we move through the lecture. We may just provide one type of utility, or we might want to combine different utilities. For example, we talked about MP steam and a combination of HP and LP steam. And this all depends on what are the process requirements of our system and what level of heat utility we require for our system. We talked different types of hot utilities in the previous slide, and this slide actually just lists them here. So we could use steam, high pressure, medium pressure, and low pressure steam. We can also use the condensate of this steam, the sensible heat from the condensed steam for our heating purposes. We could also use hot water, and it shouldn't be ignored for low temperature heating. So we can use this hot water. We can use the flue gas from our furnace, and this flue gas can be used for high level of heating, so around 600 degrees centigrade, perhaps even higher than that. Then we can use the exhaust from hot oil. The hot oil we can use in the range of 350 to 370 degrees centigrade. And then we can also use heat pump reject that actually transform low grade heat to high grade heat, and that requires power to provide compression for that low grade heat to convert it into high grade heat. So depending on the temperature difference between the low grade heat and the high grade heat, it gives you the degree of compression. So obviously, if the temperature difference between the low grade heat and high grade heat is quite large, then it requires a lot of compression, and as such you have to pay for energy for that heat pump. So heat pump might not be ideal for very large differences of inlet and outlet temperatures, but if you have relatively low inlet and outlet temperature difference, then you can use heat pump as well. So again, here we have a list of different cold utilities. So we have cooling water, that is the most useful form of cold utility. Then we can have cooling air as a cold utility, and but cooling air is a kind of limited use cold utility because the temperatures of the cooling air available significantly depend on the location of the plant. Okay, so if you are in a cold country, you can use it as a cold utility, but if you are in a warm country, then you will have limited effectivity of this cooling air. We can use air preheat and boiler feed water as the cold utilities. Then we can use heat pump and refrigeration. So refrigeration is used mostly when you have temperatures way below ambient. Okay, and obviously we try to avoid refrigeration because it is very expensive. You can also use steam generation as a cold utility. Although steam is a hot utility, if we use the steam to provide heat, it is defined as hot utility. However, we could extract heat from our chemical process, and we can use that extracted heat to generate steam. And then that would be classed as a cold utility. So steam generated or steam generation of is a cold utility, while steam use as a hot utility. Okay. So how do we decide that which of those multiple hot utilities available and cold utilities available that we should use? So generally speaking, the hot utilities should be used at lowest level or at the lowest temperature. Generally, the higher the temperature of the hot utility, higher the cost. So if you have to choose a hot utility between, for example, MP steam and LP steam, and both of these utilities can satisfy the demand of your process, we would prefer to use LP steam because LP steam is at low temperature, and it means that LP steam is cheaper than the MP steam and the HP steam. Okay. So if we need to provide heat to our chemical process, we need to know at what temperature we provide that heat at, and then we want to use an appropriate utility at that temperature plus delta T min above that temperature to provide the utility, because that would then give us the lowest cost utility that we can provide for that heating purposes. And if we are able to generate utilities, we want to generate utilities at the highest temperature or at the highest level. So for example, if you have the opportunity of producing LP steam or HP steam or MP steam, you would prefer to produce high pressure steam compared to low pressure steam, because that high pressure steam would be actually much more useful for you in the process compared to LP steam. So we can make same general observations for cold utilities as we did for hot utilities. So the lower the temperature of the cold utility, the higher the cost of that utility. Okay. So if we have to use low temperature refrigeration, it will cost us way more than using a high temperature utility as cooling water. Okay, so what it means that if we have to choose between refrigeration and cooling water, always choose cooling water because it has higher temperature compared to refrigeration, so it will be of low cost. And if there is a possibility of generating coal utilities, although it is fairly uncommon to produce coal utilities in a process, but let's say if you have this possibility, then we would want to generate coal utility at the lowest possible level or at the lowest possible temperature, because that would be actually of much more worth economically for your process. Okay, because it will give you higher cost if you sell it or if you use it in your process later on. So that is the end of part one. In part two, we will talk about the infrastructure needed to generate these hot and cold utilities.